Hello everyone. Today we are going to learn about how to model a residential building and then also calculate the load calculation and finally design a municipal report for submitting it to the municipality. So let's start. At first go to the file, then new model, in this model initialization go to use inbuilt setting with and then choose display units metric SI, steel section database Indian, steel design code IS 800/2007 and concrete design code IS 456/2000. Okay. Now go to custom grid spacing and then in the story dimension go to customary story data. Check these two and then click on grid only and okay. After doing that, three windows will pop: Model Explorer, window 1 and window 2. And the grids and elevation will be shown up. We do not need this Model Explorer, so cross this, and we can also uncheck the 3D view for now. Let us start our modeling part. At first go to edit storage system and grid system, add new grid. So let us put our grid name as GRID1, and we also need to see that in X grid labeling the grid starts from A and in Y grid labeling it starts from 1. So okay, we can delete that G1. Now in that grid we need to put our value, so go to modify or show grid system and in this here are two rectangular two grids, one can be displayed as ordinates and other as spacing. If you want in ordinate we need to accumulate the value. For example, if the center to center value is 12 and then other value is 12, then first portion it will be 12 and in second portion it will be 24. So we will go from spacing, so tick on this and then we have along x-axis 12 feet, 4 feet and 12 feet, and along y-axis it's 11 feet, 12 feet and 12 feet. So along x-axis it's 12, 4 and 12. So 12 feet, 4 feet, 12 feet, and final should be 0. And again in y-axis it's 11, 12, 12. So 11 feet, 12 feet, 12 feet. Okay. And again go to modifier show story data for elevation. Initially it's base and then base to ground floor, and then make it this as story 1, story 2, story 3 and the height from base to ground floor is generally taken as 5 feet, so 5 feet, and then story 1 is let us take 33 meter in height. So the elevation is our total building elevation is 10.524. So now let us go to master story. While designing a beam, if we want the similar beam in all story, then we can use this master story tabular format. So if you want the plinth beam, the same size plinth beam to appear in all story 1, story 2 and story 3, then you can do simply as yes, and then similar to ground floor. Here also similar to ground floor. I will show you in later if you are getting confused a bit. So do your no, and then ground floor. Okay. So let us check our 3D view, which looks like this. Go to plan, ground floor plan. Okay. Now go to define section, and then we need to define material first. So material, add new material, region India, material type concrete, standard Indian. So let's take our column of M25. Okay, M25. Okay, and again add new material. For beam, let us take M20, beam and slab. Okay, again let us add a rebar HOSD FE500, because FE500 is generally used nowadays. So okay, M25, M20 and FE500 material has been defined. Now after that, let us go to section properties, frame section. We can delete all these multiple properties, so go to delete all multiple properties, select all, delete selected frame. Okay, now add new property, concrete rectangular. So let's say beam 9 by 14. Material type, for beam we take M20. So depth is 14 inch and width is 9 inch. And then go to modifier, show modifiers, take torsion constant as 0.01. For beam, take moment of inertia about second and third axis as 0.35. Similarly 0.35. Okay, modifier show rebar, and then check on beam SOST 500, centroid cover 32.5. Similarly bottom bar also 32.5. Okay, and then click on OK. Now we can delete this. Again add new property, concrete rectangular, column. Column 12 by 12. Column M25, 12 inch by 12 inch. Now then go to show modifiers, torsion constant similarly 0.01, moment of inertia about second and third axis is 0.7 in case of column. You can check this in the code, it is written clearly in the code. Okay, now modifier show rebar, column longitudinal bar FE500. Okay, we did not need to change all of this value because we need to design our reinforcement, so we can keep it as usual. So let us do OK. Okay. Okay, now let us draw a beam starting from ground floor. In the left portion there is draw quick beam slash column plan. So, and then while drawing beam you can simply do similar story and then draw a beam 9 by 14. Yeah, it's okay. So let's draw a beam. You can check one by one like this, or you can simply perform another method. I will show you. We can take these three and these. Okay, now all the beams, we can see all the beams are separate, but in this portion when you select all, it has become, oh sorry, okay, we have selected all these beams. Now go to, okay, let me teach you one thing. In case you delete this beam and then go to this beam and then select all, okay. Okay, after doing this in ground floor, it will simply be modified in all the floor, as you can see in 3D. Yeah, because we have done similar story. So 1 2 3 4. Now let us draw a column. For that you need to at first go to the plan, go to the ground floor, okay, and then check similar stories to all story. Now draw a column. Make the property as column 12 by 12. Now draw a column. Okay, and this column has been assigned automatically to all the floors, as you can see in 3D. Go to plan and then go to base, okay, and then change all story to one story because we need to restrain our base. Select all these and then go to assign, joint, restrain, and then choose this, okay. Our base has also been strengthened, restrained. Let's see in one color, okay. You can see the tick mark in here. Check in this and then go to object assignment and then section, apply, okay. Now we can check once before doing our further process. Beam, all the beam has been assigned properly in story 1, story 2, story 3. Similarly in elevation, all elevation has been named as column, as you can see. So let's go to this and then object assignment, uncheck this, apply, okay. Now after drawing beam and column, we need to draw a slab. So we generally we need to draw slab in story 1. So okay, this is our story 1. So before drawing in story 1, we need to do some things like go to edit story and grid system, modifier so story. Now we have made the ground floor beam similar to all the beam, but now we need to change this. So because slab starts from story 1, so do no, and then story 1, yes, similar to story 1, similar to story 1. Okay. Okay, now 1 story 2, similar stories. Now we can draw a slab. From this, draw rectangular wall plan. Okay, let us draw a slab now. Slab 1. It's sorry, we need to define it first. So go to define section properties, slab section. Let us delete blank 1, delete property. Okay, now slab 1, modifier so property, slab 1 to slab only, and material is M20 slab, and this modeling type should be cell thin. There is a lot of difference between cell thin type of slab and membrane. I have written some difference between cell thin slab and membrane. So if you do this for membrane, then there is no moment in the slab, there is no shear force in slab, slab flexure stiffness is 0, and it cannot be designed while designing a slab. It must not be used while designing a slab. If you use cell thin, then it takes moment in the slab, it takes shear force in the slab, and slab flexural stiffness is considered, and it is also mostly used for designing. So let us take slab of thickness of 125 mm. Okay, now let us draw a slab. Make the property to slab, and then now it starts drawing a slab. There is also another method. You can simply, it is done to utilize our time. So if we do this, all these will be considered as one. So in order to separate this, select the slab and then two joints, and then go to edit cell, divide cell, go to this first one, cookie cut, floor object at selected frame, and then okay. Now it has been separated. Let us say there is staircase in this region, so let us delete this portion. Delete. Now we can see in 3D it has been assigned to all floors. Plan. Okay. Now if we need to offset these things, we can simply do by this process. Check this, select these three beam in y-axis, and then go to edit, replicate. Here is a choice called linear, so this is in y direction, so 0.6. let us offset this. Okay, sorry, this is in x direction. So in x direction 0.6 apply. Oh, I forgot to select the objects. First we need to select the object and then apply. Again minus 0.6 because it is in opposite direction. Apply. Again for y direction put x at 0 and then 0.6, select the object, apply, and again minus 0.6, select, apply. Now we can simply close these things and then make a slab. It's okay now. And now we can simply delete these beams because it has been assigned as beam. So let us select all these. Okay, now we can see in 3D view all these things has been assigned. So in this portion we need to cover our staircase. So right click, add or modify grid. So to modify our story, we need to add one story. Right click in here and add story. Keep the existing story height. Okay. Now story 4 has been added. And then we can simply do okay. Okay. Since we have done this all to similar story, so story 4 has also been changed. So change this to one story and then go to plan story 4. Okay. And then we just need staircase cover, so we can delete other portions. And then now we need to offset 0.6 meter here. So go to edit, replicate, and then apply, apply, 0.6, apply, minus 0.6, apply. Okay, now let us draw a slab. And then simply delete these beams. And then we also need slab in the section. So make a slab here. Okay, let's check in 3D. Edit, well, our view looks like this. Well, after assigning all these things, now it's our turn to assign load. So go to plan, ground floor. Okay. For defining load, we first need to define some patterns. So go to define and then load pattern. Dead load is 1 because we do not put load in beams slab because it will get multiplied by 1 itself by itself at multiplier. So dead load is 1, live load is 0, and other load we generally consider is partition wall load. It is dead and it is 0. Add new load, water tank, add floor finish, add live load, change this to live, add a live load is already there, so we can delete this load. Now seismic load, EQX, change this to seismic, and then IS. Okay, define load pattern, EQX, seismic, add new load, again EQY, add new load. So in EQX we need to modify lateral load system, so modify lateral load, and for X we need to uncheck all those in Y direction, and response reduction factor, yeah, we did not need to write all these things. If the soil type, we can also choose soil type. If there is hard, medium and soft, you can choose this. Now we can now in this case I am taking medium. So time period, we can simply write our user defined time period, which is 0.075 into h to the power 0.75. So let us take the height. Let us take our building height. So for that you need to right click, add or modify grid, modifier, so story data. Here 13.524 minus 1.524 is 11. So okay, now define load pattern, EQX, seismic, add new load, EQY, add new load, go to modify lateral load, uncheck all in X direction while performing Y, and then go to user defined, and then 0.075 into 11 to the power 0.75, 0.45. Okay, again modify lateral load, uncheck all in X direction, our value was 0.45. okay, and then again go to define, after load pattern go to load combination, default design combos, concrete frame design. Okay, and then go to the mass source modifier, so mass source, uncheck this first one, and then check on specified load pattern and additional mass. Two things should be checked, so keep on adding, and then go to live load. One thing we should consider during the live load is less than 3 or greater than 3. In case of simple residential building, live load is less than 3. So For live load less than 3 we take 0.25, and for live load greater than 3 we take 0.5. Partition wall load it's 1. And again water tank it's 1, floor finish it's 1, and in load pattern we should not mention EQX and EQY, so okay. Mass source has also been made, and again go to define and then diaphragm. Modifier show diaphragm. Okay, add new diaphragm. Okay, we have also added a diaphragm. And then mass source has also been added, load pattern, load combination, yeah, this much in. So now let us add load. So for an instance, this is a ground floor plan, and I have made some tutorial here. For load calculation we need to consider one thing. We know the unit weight of wall is 19 kilonewton per meter cube, so we need to give the load in per meter. So 19 kilonewton per meter cube into meter, it's 2 meter cancel, then kilonewton per meter. So for load calculation without opening, our total height is 2.87 minus beam depth is 0.35. If we minus this by this, then comes the clear height of a wall, and then multiplied by 19 into wall thickness is 0.23, 11.01. Similarly with opening, it's we need to separate 20%, so 11.01 into 0.8 it's 8.8. For half wall similar is the process, but only the brick thickness is 0.11, and with opening it's 4.21. So let us assign the loads. For assigning, let us assume in these sides there are no windows and it's the full wall. So go to assign, frame load, distributed. Let us keep we need to assign a wall load also. Define load pattern wall. Add new load. Okay, now assign frame load, distributed wall load of 11.01. 11.01. Apply. We can see our wall load has been applied, and again let us suppose there are opening in these portions. So our load is 8.80 for full wall. 8.80. Apply. And let us take this. With half wall brick with opening, I am taking half wall brick 4.21. 4.21. Apply. Now go to above. Check all the assign frame load distributed 8.8 apply you can calculate the load and then apply. I'm doing this for fast purpose, so I will select all and then apply similar load. Apply. Here partition wall, so I just let us suppose it will be 3. Apply. Okay, all our wall load has been assigned. Now we need to assign a live load, so select the slab and then assign, go to below, this beam should be deleted. Now let us take a live load, select all slab, assign cell load uniform, live load for room. Let us take live load of 2. Apply. 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 Let's select this, apply. Well, after assigning live load and also live load in case of balcony, let us select all the balconies, and then for balcony put 3. Apply. 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 Now then we have wall load, partition wall load, live load, floor finish. Let us select floors, all floors. Go up. Assign floor finish to 1.5. apply. Now in the in the topmost section there is also water tank, so we need to assign water tank load in there. Water tank, and how to calculate the water tank load, here I have. So water tank load, suppose we have 1000 liter of water tank, so 1 kg is equals to 9.8 Newton, and 9.8 by 1000 kilonewton, so 1000 kg is 9.8 kilonewton. So hence the water tank load is 9.8 kilonewton divided by area of slab. So it will be 3. You can calculate by the given formula here, and I have put on 3 in my case. Apply. Okay, I need to select the object. Apply. And now all load has been assigned now. Okay, now staircase is remaining. So for the staircase, you can, for designing a staircase, you can draw a slab and then put all the, calculate the load and then put in the slab, or you can simply give the load. You can calculate the load. For staircase we need to calculate the volume of waste slab and then trade and riser volume, and then multiply it by 25 kilonewton per meter cube, and there comes the weight of our staircase in kilonewton per meter square. So I have calculated, and then let us put me the value. Our staircase starts from, suppose here, so this is our starting of our staircase. So let us, I have calculated it as 9 frame load distributed, so I have not assigned staircase, so I will put this in the form of wall. Okay, wall load is 9. Okay, 9. Let us go to up. In this section there will be 2, so 13. I have calculated it as 14. So frame load distributed 14. Apply. Again here 14. Apply. 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 14. Only up to this portion, there will be no. Okay, you can delete this. Okay, after assigning the staircase load also, now it's time to draw a diaphragm. So for drawing a diaphragm, go to plan, stairway 1, okay, and then go to assign seal diaphragm, then D1, apply. At first we need to select the object, so select all, apply, go up, again select all, D2, apply, then go up, D3, apply, and then finally defer apply. Okay, now after doing all these things, let us go to analyze and check model. Select all. Okay, the model has been checked, no warning message were generated. Now we can simply run analysis. Let us give some name to our ETABS file. ETABS practice. Okay. It's preparing to run analysis. Now our analysis has been done. Now go to analyze. Now after our model has been run, then go to display, go to story response plot. We need to check our deflection. We can check our deflection, maximum story displacement, and then case combination for okay, let us check it for decon 1. The permissible value should be 0.04 times height of the building. So our height of the building was 13.524. 0.04 times 13.524. It's 0.54 and our permissible value is 0.54 and here is maximum 0.93, so it is okay. You can also check for drift. So remember, to calculate the permissible value, it's 0.04 times height of the building. So we need to check our drift, maximum story drift. It should be always less than 0.004. 0.004. Here in case 0.0002, and it's also okay. And our building is safe in displacement and drift. So let's go back, and now the other thing we need to check is model participation mass ratio. So go to display and show table. Show table, and then go to result. Model result. we can check this time history function. This, we can simply check the necessary things in here. So let us do okay right now. And we can use these things to put in our final result. We can also see force or stress diagram. Joint assignment. Another, there are lots of things that we can see from here. And then check here. After doing this, go to the design portion, design, concrete frame design, view revise preference. Here design code IS. So okay. Again design, concrete frame design, start design and check. It will take some time to check the our structure. Okay, our reinforcement can be seen. Let us go to the ground floor. Okay, this is the reinforcement needed. As you can see here, you can simply go up and see the reinforcement requirement. Now the reinforcement requirement in column, let us check that. We can see the reinforcement requirement in column. We can now calculate the value by, as we have studied earlier, AST is equals to pi d square by 4. So d is the diameter of rod in mm. So you can simply check the amount of or the number of rod needed in order to counteract this stress given. Then we can calculate all the related stress and force and the number of reinforcement in the relative column. After doing that, if you want to check the force in column, go to display, force stress diagram, spring or supporting reaction. Check in case of, if you want to see in combo, so Deacon 1, or Deacon 2, you can check for Deacon 1 or Deacon 2. And MX, MY and FZ. Okay. And we need to divide all these force reaction by 1.5 because Deacon 1 means 1.5 times dead load plus live load. So if we divide by this, then we will get the support reactions of our building. In tabular form, you can go to display and show tables, and then we can see these reactions and then copy it in Excel. Well, if you follow these rules, then you can simply draw any analysis of a building structure. And if you want to see the final report of the ETABS, then I think I have one. Where did I put that? Okay, well, I will make another video for that about how to make municipal final report. So please, if you find this class effective, then please like, share and subscribe this video, and then motivate me so that I will make another interesting videos about ETABS and other related stuffs. So please like, share and subscribe this video. Thanks for watching.